Okay, this is going to be a quick lesson about direct and inverse variation. So we are just going to look at those two types of problems. So starting off with direct variation. So if I had a phrase such as y varies directly as x, that means y equals k times x, where k is just some constant. What type of function are we used to being a direct variation? Hopefully you're thinking a linear, because that represents y equals mx plus b. So if I'm looking at this first example, it says use direct variation equation to find the missing variable. So it says x varies directly with y. So that's important. That's going to tell us a lot of information. So if I'm writing my equation, I'm going to say x varies directly with y. So x would equal y times k, or k times y. So x is going to equal y times some constant. And we're going to figure out what that constant is first. So step A says find the constant. Well, it gives me this information over here. It says x is -5 and y is 2.5. Okay, so I'm going to plug that in. So I'm going to say x is -5 equals k times 2.5, and then we're just going to quickly solve for k. Divide 2.5 by both sides. So then k would equal -2. Okay, part A is complete. We found what the constant equals. Alright, so I'm going to take that information about what the constant equals, and we are going to find y when x equals 6. So for part B here, I'm going to take that information. I'm going to say y is the unknown. So x equals k y. So I'm given x is 6 equals k is -2. So I can divide by -2. So y would equal -3. So on this next example, it says A varies directly with B. Okay, so if I'm looking at that, that would mean that A equals some sort of constant times B. Step 1, we want to find the constant. Well, if A is -1/2, when B is -3/10, we can use that information to figure out what the constant of proportionality would be. So let's plug this in. So -1/2 equals k times -3/10. And then hopefully you're thinking multiply by the reciprocal. So k would equal 10/6, positive 10/6. I'm going to reduce that to 5/3. Okay, so k is 5/3. I can use that information to plug it in to figure out, find A when B equals 5/9. So I can, part B, find A when B equals 5/9. So A is the unknown, K was 5/3, B is going to be 5/9. So what's A going to equal? 25/27. And that's it. Okay, let's look at an application problem. So it says many areas of Northern California depend on snowpack of the Sierra Nevada mountain range for their water supply. The volume of water produced from melting snow, there should be no H there, varies directly as the volume of snow. Meteorologists have determined that 250 cubic centimeters of snow will melt to 28 cubic centimeters of water. At what rate is the snow melting? And how much water does 1,200 cubic centimeters of melting snow produce. All right, let's look at that important sentence in here. It said the volume of water produced from melting snow varies directly as the volume of snow. All right, I'm going to come up with some variables that relate here. So the volume of water produced from melting snow. So we're talking about the water produced. So I don't want to use V because we're talking volume of the water produced and volume of the snow. So I'm just going to say this is W equals. Directly is vary as the volume of the snow. So I'm going to say K times, I'm going to use a dangerous letter there, S. Okay? So let's first find the constant. So it says they have determined that 250 cubic centimeters of snow will melt to 28 cubic centimeters of water. So I'm going to plug in what we know. So I know that the water is 28. I know the snow is 250. So I can divide by 250. So here K would equal 14 over 125. If you wanted to look at that as a decimal, that would be 0.112. So that is my rate at which the snow is melting. So if I look at how much, let's see what it says. How much water does 1,200 cubic centimeters of melting snow produce? So how much water? So the unknown is the water. My constant was 1,425ths. And then times 1,200. All right, so if I multiply that, I will approximately get 134 centimeters cubed. Okay, let's look at the next one. So how much water does it produce? 137 centimeters cubed. All right, the distance required to stop a car varies directly as the square of its speed. Okay, that's kind of an interesting problem there. Let's highlight that sentence. The distance required to stop a car. Okay, well, I'm going to use D for distance. Varies directly as the square of its speed. So hopefully you're thinking that would be K times, I'm going to use X for the speed. Okay? So I'm going to use D for distance and X for speed. And it says squared, so that's why it's X squared. The square of its speed. So if 200 feet are required to stop a car traveling 60 miles per hour, how many feet are required to stop a car traveling 100 miles per hour? Okay, so let's use that first information. 200 feet are required to stop a car traveling 60 miles per hour. So I'm going to plug in 200 equals K times 60 squared. Well, we want to get K by itself, so we can divide by 60 squared. 60 squared is just going to be $3,600. And now I can divide 200 by 3,600 and simplify, so that would give me 1/18. All right, so my constant is 1/18. So let's apply that to, okay, so we're going to use that in using the information that we want to figure out how many feet are required to stop a car traveling 100 miles per hour. So if I rewrite my direct variation here, so my constant was 1/18, and this time it's 100 miles per hour, so that'd be 100 squares, so we want to figure out the distance. So if I calculate that, it's going to be approximately 556 feet. The next type of variation we're going to discuss is inverse variation. So if it says y varies inversely as x, that means we are going to take that constant and divide it by x. So it's going to be y equals k divided by x. If I was to graph this, it would look like an exponential function. All right, we're going to jump right into an application problem. It says when you spray a can, you decrease the pressure of the gas in the can. The decrease of pressure causes the volume of the gas in the can to increase. Because the gas needs more room than is provided in the can, it expands in spray form through the valve. In general, if the temperature is constant, the pressure P of the gas in the container varies inversely as the volume V of the container. All right, let's pause right there and highlight there. If the temperature is constant, the pressure P of the gas in the container varies inversely as the volume V of the container. So if I was to write an inverse variation, it would be P equals K divided by V. So it says the pressure of the gas sample in a container is 12 pounds per square inch with a volume of 8 inches cubed. All right, let's look at what that would mean for my constant. So if the pressure is 12, the constant is unknown, the volume is 8. We can quickly multiply 8 by both sides. So the constant would be 96. So I'm going to take that information and plug it in with my what I'm trying to find. If the sample expands to a volume of 22 inches cubed, what is the new pressure of the gas? So I would say, okay, pressure is unknown. It equals 96 divided by 22. So if I divide those, I would get around 4.4. And that's 4.4 pounds per square inch. Okay, let's look at this next one. Well, this is just kind of like a quick recap. When it's direct variation, we would just multiply by the constant. When it's inverse variation, we're going to divide the constant by whatever is inversely related. All right, for these last two problems, it's a little bit more complicated. It kind of combines the two. So if y varies directly as x and inversely as y, and y equals 24 when x equals 48 and z equals 4, find x when y equals 44 and z equals 6. So I want to read that first part again. If y varies, okay, so if y equals directly with x and inversely with z, so that would be k times x, but inversely with z, so that'd be divided by z. Okay, so let's plug in what we know. Y is 24, k is unknown, x is 48, and z was 4. Well, I'm going to simplify this right-hand side. 48 divided by 4, that's going to give me 12k. So if I divide, k is 2. So let's use that information. It says find x when y is 44 and z is 6. So we're going to say, okay, y was 44, k is 2, x is unknown, over z, which was 6. So if I divide 2, 6, that's going to give me 1/3, and then I can multiply by 3. So x would equal 132. Okay. The last one is about IQ. So one person's intelligence quotient, or IQ, varies directly as a person's mental age and inversely as that person's chronological age. A person with a mental age of 25 and a chronological age of 20 has an IQ of 125. What is the chronological age of a person with a mental age of 40 and IQ of 80? All right, let's go back and see here what's happening. So the IQ varies directly as a person's mental age and inversely with a person's chronological age. So I'm going to use I to represent the IQ, equals K for my constant, M for mental age, so it's directly with the mental age and inversely with the chronological age. So plugging in what we know, so I'm going to say, okay, 125. So a person with a mental age of 25, chronological age of 20 has an IQ of 125. So that would be 25K over 20. I can simplify 25 20ths to be 5/4. So I can get rid of this by multiplying by 4/5. And K would equal 100 then. So using this information, what is the chronological age of a person with a mental age of 40 and an IQ of 80? So I can plug that in. So 80 equals 100 times 40 over C. We don't know the chronological age. I can't do anything with C in a new denominator, so I'm going to multiply that by both sides. So I'm going to get 80C equals 4,000. And I could divide by 80. So the corresponding chronological age would be 50 years. Okay, you have a quick assignment to do when you are done with these notes.